So in 2-3, we talked about, or actually 2-4, excuse me, we talked about the law of detachment and the law of syllogism. So the law of detachment says that if you're given an initial conditional and we're given that as if it were true, right? If P then Q, then if you're given the hypothesis, you can conclude that the conclusion is true. All right. So it seems kind of obvious, but the ones to watch out for are if you're given the conclusion, you cannot make an assumption about the hypothesis. If you're given that the hypothesis is not true, you cannot make an assumption about the conclusion, or you cannot make any conclusion there. And so let's look at an example and just try to make sense of this. So the first one, if a doctor suspects her patient has a broken bone, then she should take an x-ray, right? And then it says Dr. Nagemba suspects Lily has a broken arm, right? So here our hypothesis is a doctor suspects her patient has a broken arm, and they give us the hypothesis, right? So that means we can conclude that Lily should take an x-ray, right? So if we're given the hypothesis, we can conclude that the conclusion is true. On the other hand, number 7, if a rectangle has side lengths 3 centimeters and 4 centimeters, then it has an area of 12 centimeters squared. Then they tell us rectangle has an area of 12 centimeters, right? So they just gave us the conclusion, but we can't conclude that the hypothesis is true, right? For example, we could have a rectangle with side lengths of 2 centimeters and 6 centimeters and the area is 12, right? So just because the conclusion is true doesn't necessarily mean the hypothesis is true. And this goes back to the truth values, right? The converse doesn't always have the same truth values as the original conditional. Okay, same thing with if I say not P, right? So if you look at number 9, if an angle is obtuse, then it is not acute, right? So then they tell us the angle is not obtuse, right? So they're negating the hypothesis. And so if an angle is not obtuse, it actually can be acute, right? And so, or it might not be acute. So we can't make any conclusion based on the negation of the hypothesis. Okay. Now, one that I didn't notice coming up in the example is the original conditional does have the same truth value as the contrapositive, right? So the contrapositive is if not Q, then not P. So if you're given not Q, then you can conclude that not P is true. Going back to number 7, if I say that the area is not 12 centimeters, right, squared. So if I say not the conclusion, then you can assume that the side lengths are not 3 and 4, right? Because if they were 3 and 4, then the area would be 12. So there's no way that the area cannot be 12 and the sides can be 3 centimeters and 4 centimeters. And so this is one that actually does work. All right, so that's the law of detachment. Now the law of syllogism is kind of like the domino effect, right? Or like the transitive property of equality, right? So basically, if P then Q is true, and if Q then R is true, right? So you can go then, if in other words, if the conclusion of one conditional matches up with the hypothesis of the other, you can go straight from the first hypothesis to the last conclusion, right? So you can say if P then R, right? So it's the domino effect, basically. All right, and remember, you can have as many iterations as you want. You could say the next statement is if R, then T, and so you can go straight from P to T in that case, right? So that can be, you can have multiple iterations of the law of syllogism. All right, now the ones to watch out for. If I say if A then B and is true, and if A then C is true, you can't really make a conclusion with that based on the law of syllogism. So no conclusion there. So if the hypotheses match up, that doesn't hold the law of syllogism. So same thing, if the conclusions match up, you can't do anything with that either. You can't make a conclusion. Now, I wanted to show you this one here just because sometimes the order is backwards, right? So the order doesn't matter if they give you the conditional statements backwards, as long as you have the hypothesis of one match up with the conclusion of the other. You can go from the non-matching hypothesis to the non-matching conclusion. Okay, so you can say if V, then X in that case. All right, and remember, you can use these in conjunction as well. So I can give you a situation like this, and then I can say, okay, now, or I can give you a situation like this, I should say, and then I can also say, okay, well, P is true. So then you can conclude ultimately that R is true. Okay, so you can write the one conditional based on the law of syllogism, and then you can use P to conclude, oh yeah, well, that means R must be true. Okay, so you can use the law of syllogism with the law of detachment at the same time. And you'll see some of these examples ask you to do that, right? Like 15 and so forth. All right, so here are some others. I didn't get into the examples too much because I don't want to make the video too long. But yeah, once again, just practice these. Let me know if you have any questions, and just make sure that all of this stuff makes sense.